whatever the data bit we have, for that we are going to append the extra bit, and that is known as redundant bit. Here C1 is nothing but the parity bit P3 and C2 is nothing but the parity bit P2 and C3 is nothing but the parity bit P1. The name of the error detection as well as error correction technique is Hamming code. Hello friends, a warm welcome to my new session on the data link layer. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have discussed in my previous session. In my previous session, I started with polynomial course. In that, I have explained CRC. So what is CRC? That is nothing but the cyclic redundancy check. So here we are going to generate some redundancy bit. I'm going to append that bit with my data and I'm going to send that data to the receiver. And at the receiver side, I'm going to check the data in order to verify that whatever the data is received, that is identical to the original data or not. But in my today's session, I'm going to discuss one more error correction technique, that is Hamming code. So if I consider this Hamming code, it's an error detection technique or it's an error correction technique, and it is used to correct only one bit error. And if I consider errors, there are two types of errors, single bit error and burst error. By using Hamming code, I can able to correct only one bit and it is called single bit. Now let me to discuss what is Hamming code and why it is called Hamming code. So here Hamming code is a technique used to correct the error, which is an error in the sense what? The error occurred during the transmission of data. So what is error here? Here error is nothing but the data bits are get corrupted. In the sense what? The bits are get toggled from 0 to 1 or 1 to 0. So here Hamming code is nothing but a error detection as well as error correction technique, and which was proposed by the Hamming, R.W. Hamming. So here who proposed this technique? That is R.W. Hamming. For that reason, the name of the error detection as well as error correction technique is Hamming code. So whenever a data packet is transmitted over a network, there are the possibility of data bits may get lost or damaged during the transmission. So what is the meaning? While transmitting the data bit may corrupted or damaged. So to identify that which bit is damaged, we are going to use Hamming code. According to this technique, we are going to have the redundant bit. So dear student, what is redundant bit? It's an extra bit. Whatever the data bit we have, for that we are going to append the extra bit, and that is known as redundant bit or the some extra bit. So I am going to append some extra bit to the original data bit. It's not the part of the original data. So dear student, if I consider original data, okay, for that I am going to append the extra bit, and for that extra bit is called redundant bit. Now, according to this Hamming code, see here, what I required 2 to the power P. So here P is nothing but the redundant bit that must be greater than or equal to M plus P plus 1. Or I can write 2 to the power P, which is greater than or equal to P bit, that is redundant bit, plus message plus 1. So what's the meaning of 1 here? That's nothing but no data bits are corrupted. So here 1 indicates that none of the data bits are corrupted. Then what about P? P is nothing but the redundant bit or parity bit. And what about M? M is nothing but the original data or data bit. Now see here, when I substitute P value and if I take the 2 to the power P, that must be greater than my redundant bit plus data bit plus 1. Okay, fine. Now let me to start substituting P value, that is redundant bit value. Suppose if P is 1, okay, 2 to the power 1, it is 2 greater than or equal to 1 plus M. So that is nothing but my data bit. For example, say it is 0, 1, 1, 0. So how many bit? 4 bit. So 4 plus 1. So it is 2 greater than or equal to 1 plus 4, it is 5. 5 plus 1, it is 6. Okay, fine. So this condition is false. So P equal to 1. My parity bit cannot be 1 here. Okay, fine. Now what I will do, I'll take P equal to 2. Okay, fine. Now what's the formula? 2 to the power P. That's nothing but 2 to the power 2. It is 4 equal to P plus M plus 1. P is 2 plus M is nothing but the 4 plus 1. It is 7. Now 4 greater than or equal to 7. Is it true or false? It is false. What I want to do now, I want to assign P equal to 3. Why? Because here 4 greater than or equal to 7 is false. So what I want to do, I want to assign P by 3. So that is P equal to 3. Then what's the formula? That is 2 to the power P. Here P is 3. 2 to the power 3, it is 8 greater than or equal to 3 plus 4 plus 1. Over. So here 8 greater than or equal to 8, the condition is true. In the sense what? For 4 bit of data, I can able to add 3 parity bit. I repeat, for the 4 bit of data, I can able to add 3 parity bit. In the sense what? I can append 3 parity bit. So, from the formula, we can able to calculate the parity bit. Okay, fine. Now, let me to consider some example. Before that, let me to write the formula here. So, what is the formula used to find parity bit? That is 2 to the power P. 2 to the power P, which is greater than or equal to P plus M plus 1. So, what is the meaning of 1? That is, no data bits are corrupted. Okay. Now, what is P? That is nothing but the parity bit, and M is nothing but the data bit. Okay, fine. Now, let me to consider the example here. Think that I have the data bit, that is 0, 1, 1, 0. Now, what I will do, I'll consider this one, my M1, and this is my M2, and this is my M3, and this is my M4. Okay, fine. Let me to rewrite this one once again. Okay, so 0, 1, 1 and 0. So it is my M1, it is my M2, M3 and M4. Okay, fine. Now, according to this length of the data, what is my parity? That is P equal to 3. So, what are the possibility? That is P1, P2 and P3. Okay, fine. Now, if I consider 2 to the power 3, if I consider 2 to the power 3, what are the possible combination I am going to get? So, it is 2 to the power 3, that is nothing but 8. Over. So, here I'll take C1, C2 and C3. Now, let me to write all the combination here. So, 0 is nothing but 0, 0 and 0. Okay, fine. Now, if I consider 1, how can I represent 1 in binary? That is 0, 0 and 1. Okay, fine. If I want to represent 2, how can I represent? That is 0, 1, 0. And for 3, 0, 1, 1. Okay, for 4, it is 1, 0, 0. To represent 5, I have 1, 0, 1. To represent 6, 1, 1 and 0. To represent 7, it is 1, 1 and 1. Okay, fine. Now, P3 is nothing but my C1. Okay. P2 is nothing but my C2. Okay, fine. Then P1 is nothing but the C3. Okay, now I want to write C1. C1. Okay, fine. See here, if I consider this C1, wherever I get 1, okay, I want to consider that one. See here, okay, here, see, 4, 5, 6 and 7. Okay, fine. If I consider C2, okay, C2, wherever I get 1, okay, that is 2, 3, 6 and 7. And if I consider C3, that is, see, it is, C3 is 1, then 3, it is 5 and 7. Okay, fine. And if I consider C1, C2 and C3, see here, this is repeating, this one is repeating and this one is repeating. Okay, fine. And if I want to send any data from sender to receiver, there must be a agreement between sender and receiver. And how the Hamming codes are generated or how the Hamming codes are organized, that is, I have data bit M1, M2, M3 and M4. Okay, fine. And if I consider my parity bit, how I am going to append parity bit with the data? See here. So, here C1 is nothing but the parity bit P3 and C2 is nothing but the parity bit P2 and C3 is nothing but the parity bit P1. Okay, fine. Now, see here, which are the bits are unique here, that is 4, 2 and 1. And other numbers are repeating. Okay, so here I want to consider only the unique number. So here in the place of 4, it is P3. Okay. Now, in second place, I must have the P2. And P3 is nothing but P1. So, in P1 place, I am going to have the parity 1. Now, in rest of the field, I am going to fill data bit M1, M2, M3 and M4. Okay, fine. Okay, I repeat. See how I'm going to form this Hamming code. See here, I'm going to consider this C1, C2 and C3. And if I consider all the digit, see here, 5, 6, 7, it is repeating, 3, 6, 7 repeating, 3, 5, 7, it is repeating frequently. Okay, here I want to consider only the unique numbers, that is 4, 2 and 1. Otherwise, do one thing, consider only the first numbers. Now, how I have assigned C1 is nothing but the P3 and C2 is nothing but the P2 and C3 is nothing but the P1. Okay, fine. Now, what I will do, C1 is nothing but P3. So, where I have P3? In the place of fourth digit. Okay, I have P3. Okay, fine. And if I consider C2, C2 is nothing but the parity bit 2. And where I want to place? At the position 2. So, parity bit 2. Okay, fine. Now, if I consider C3, C3 is nothing but the P1. C3 is nothing but the P1. In the place of P1, I want to write P1. So, in first place, I am going to write P1. And in the rest of the place, see, I'll write M1, that's data bit 1, data bit 2, 3 and 4. Now, what I want to do, I want to consider my data bit, that is 0, 1, 1, 0. See here, data bit M1 is nothing but the 0, M2 is 1, M3 is 1 and M4 is 0. Okay, fine. Now, I want to find parity bit 1, that is P1. How can I find? See here. P1 is nothing but the P1 is nothing but the C3. So, I want to consider this C3 and see 3, 5 and 7. I want to consider 3, 5 and 7. Okay, so here I'll start from 1, 2, 3, 4, 5, 6 and 7. So, what I want to consider? 3, 5 and 7. I want to consider 3, 5 and 7. See, it is 0. Here it is 0 and I am going to have only 1. So, to make it even number of 1, what I am going to do? I am going to write 1. Because here I am going to have only 1. So, it is an odd number. To make it even number, what I will do? I will write 1. Now, here C2 is nothing but the P2. Now, I want to consider or I want to find parity bit 2. So, which are the place I want to consider? 3, 6 and 7. So, 3, 6 and 7. If I consider 3, it is 0. 7, it is 0. So, 2 zeros and only 1, 1. So, it is odd number. 1 is odd number. To make it even parity, what I will do? I am going to place 1 here. Now, C1 is nothing but the P3. So, now I want to find parity bit 3. To find parity bit 3, what are the numbers I want to consider? 5, 6 and 7. I want to consider 5, 6 and 7. See here, I am going to have 2 ones. It is even number and 1, 0. So, I have even number of ones So what is my parity bit? It is 0. So what is my Hamming code for this data? It is 110011 and 0. Okay, fine. Now I'm going to send this to receiver. And at the receiver side, if receiver is going to receive same data, then it indicates that the data bits are not corrupted. If any one of the bit is get corrupted, okay, if any one of the bit is get changed, then I want to find out which bit is corrupted. For example, say if my data bit 11011110. Sender is going to receive this data. Now sender is going to check. Okay, sender is going to check which data bit is corrupted. Okay, and if I see this one, which bit is changed? Which bit is changed? That is fourth bit. So where I have fourth bit? So it is 100. See here. First three bits are as it is and the fourth bit is changed. See here. Fourth bit is changed. Where this fourth bit I am getting? That is 100. This is the way I can able to perform Hamming code. So Hamming code is a error detection and error correction technique. And anyway, dear student, in my next session, I'm going to deal with the elementary data link protocols. Until that, keep watching and keep learning. Thank you.